Okay, we are going to continue today with the Honors Pre-Calc B Semester Exam Review 2015-16, and we're going to start off with number 14. And number 14 is a multiple choice question. It says, which of the following statements is false? And then it has 4 different choices. So to start off, I'm actually going to graph the functions ln of x, e to the x, and e to the negative x, because that's what all the questions are referring to. So first let's start with ln of x. So remember that e is approximately 2.718, and ln of 1 is 0, ln of e is 1. We have a vertical asymptote at x equals 0, so the function looks like this. Okay, then we have the graphs. I'm going to do these actually on the same graph, e to the x and e to the negative x, which are just reflections across the y-axis. So e to the 0 is 1, e to the negative 0 is still e to the 0, so that's still 1. So here is, we'll call it g of x equals e to the x, and e to the negative x is reflected across the y-axis. We'll call that h of x. Okay, and these both have horizontal asymptotes at y equals 0. Okay, so option A, f of x equals ln of x has a domain of all real positive numbers. So if you look at ln of x, the domain is obviously not including 0, okay? And it does include all positive real numbers, which is what the option is giving us. So this is actually true. So A is true. And if you look, the question is actually asking which one is false. B is also true, because if you look at ln of x, it's increasing without bound as x increases without bound. In other words, as x approaches positive infinity, f of x approaches positive infinity. So B is also true. C is also true. I actually said that earlier when I was graphing both of these. They're just reflections of each other across the y-axis, which means that D is the answer, which is false. And you can see that it says g of x equal to e to the negative x. So I guess I flipped these around a little bit. They're talking about this one here for g of x. It has a range of all real numbers, and that's not true because there's a horizontal asymptote at y equals 0. So again, the answer is D. Okay, let's move on to number 15, which is also a multiple choice question in regards to log base 5 of 5 over x cubed. And it's asking us to basically expand this. So using our properties of logarithms, the division becomes log base 5 of 5 minus log base 5 of x cubed. Again, because it's division, it becomes subtraction. Log base 5 of 5 is 1, because 5 to the first power is 1. I'm sorry, 5 to the first power is 5, so log base 5 of 5 is 1. And this guy here, we can bring down by the power rule, bring down the 3 out front. So we have 3 log base 5 of x, which is option B. So the answer here would be B. All right, we're going to continue with some properties of logarithms. The next few questions are still multiple choice. So let's look at 16. So if you look at 16, it says, which of the following is equivalent to log base 10? Remember, you don't have to write the 10. It's assumed that it's base 10 if there's no base written, of y squared over the square root of x. Now I'm going to write the square root of x as x to the 1/2, okay, which is just the rational exponent form of the square root of x. So again, we have division, so we can split it by subtraction. Log base 10 of y squared minus log base 10 of x to the 1/2. We can use the power rule for both of these and bring down the exponents. And if you look at the options here, the answer is B. That's exactly what I just got. So this is B. Okay, next one, number 17. Which of the following is equivalent to 3 ln, the natural log, or log base e of x, plus ln of z minus ln of y? Now, addition and subtraction are on the same level as far as order of operations. And this time I'm actually going to condense all of this. So it doesn't matter if I do the addition or subtraction first, but first I'm actually going to bring up the 3. Okay. Then I'm going to combine these two using the addition product property. So ln of x cubed z times z minus ln of y. And lastly, I'm going to use the division subtraction property, and I get that. And if you look at your options here, that is option C. So the answer is C. Okay. All right, number 18. Moving right along here. Which of the following is equivalent to log base 10 of 20 over log base 10 of 2? Now here, you have to know the change of base formula. So let's just review that real quick. Change of base. Okay, if I have, let's just say log base b of a is equal to log base 10 of a over log base 10 of b. So in other words, the b stays below, which is also equivalent to ln of a over ln of b. Okay, so here it's the change of base formula in reverse. So this actually becomes log base 2 of 20. Okay, and you can see that that is option C. So C is the answer there. Okay, let's continue with number 19. So we have log base 7 of 6,904. So if you go onto your graphing calculator, TI-83s, I believe the TI-83 Plus or TI-84, one of those versions, you can actually do this without the change of base formula, but otherwise you can only do base 10 and base e, or the natural logarithm. So I'm going to use the change of base formula here. Again, you can do ln of 6,904 divided by ln of 7, or log base 10 of 6,904, which is what I'm doing, over log base 10 of 7, which, so again, this is equal to ln of 6,904 over ln of 7. And if you do this in your calculator, and it says round to 3 decimal places, you get 4.543. Okay. Number 20, exact same idea. Log base 4 of 0.0123. So again, you can evaluate either of these in your calculator. And if you do that, you get negative 3.173. Okay. Okay, number 21. 21 and 22 are both asking us about transformations of functions. So they say, let f of x equal 3 to the x, and they want us to write a new function g of x that's a transformation of the parent function f of x equal to 3 to the x. So you have reflection about the x-axis. I always like to say next to x over y, next to out front, or next to y over x. So here, if I want to reflect over the x-axis, I need to put a negative out front of everything. In other words, negate f of x. So here I'd have negative 3. And then they want a shift, or they use the word translated 5 units to the left. And horizontal translations, you do the opposite. So this would be your g of x. Okay, 22, very similar. Our parent function is 9 to the x. They want a new function g of x. Let me make that a little nicer. Reflection about the y-axis, so next to x, and stretched vertically by a factor of 7. So that is going to be 7 times 9 to the negative x. All right, moving on to number 23. So for all of these, we are solving equations using logarithms and exponents in the relationship. So with number 23, we have 3e to the 2x minus 7 equals 50. So again, you're using their inverse relationship of logarithms and exponents. So first thing I do here is add 7. Divide by 3. Take the natural logarithm of both sides so that these essentially cancel. Again, because of the inverse relationship. You can also think of it as bringing down the 2 to the x, and then ln of e is 1. So you're just left with 2 to the x, 2 times x, and divide by 2. So this would be our answer here. And they say you can leave it in terms of logarithms or round it to 3 decimal places. I'm just going to leave it in terms of logarithms because it's more exact since you don't have to round. Okay, number 24. We have 2.8 to the x equals 345. So for this one, you would want to use log base 2.8 of 2.8 to the x equals log of 2.8, 345. These here, again, log base 2.8 of 2.8 is 1, so the x comes down. In other words, they're inverse relationships. So this gives you x equals log, so you can cross those out if you want, of 2.8 of 345. And again, that's a more exact answer, or you can use your calculator, since this one does not have a no calculator symbol next to it, and you can round it to 3 decimal places. All right, 25. Okay, I'm going to go ahead and subtract 20 first. Divide by 5. Use log base 2 on both sides. Add 1. Let's continue this up here. 3x equals log base 2 of 100 plus 1. And divide by 3. Okay, and one common mistake here, make sure you do not add 1 plus 100 here. Okay, this is log base 2 of 100 plus 1, and then all divided by 3. Okay, and we'll do number 26 last here. Ln of x plus 4 equals 2. Okay, so when you are dealing with getting rid of logarithms on both sides of an equation, you do need to check for extraneous solutions. Okay, so here I have ln, or log base e, so I am going to do e raised to ln of x plus 4 equals e squared. These essentially cancel, and subtract 4. Okay, so that would be my answer. Okay, and you can see here if you plug in e squared minus 4, I'll leave that up to you. You will get out 2. There is no extraneous solution for this one. Okay, so that's the last one we're going to do with this session, and we will continue with the next one. So see you next time.